Hello everyone, welcome back. Today I will be discussing the second problem in the contains duplicate series, that is Leetcode 219 contains duplicate 2. This one is pretty straightforward on its own, and even if you haven't solved the previous one, I think you will still be able to solve this problem without any trouble. This problem can be solved using both hashing as well as sliding window technique and is a pretty good one to understand the basics of sliding window. I will discuss both the approaches and then quickly code up the sliding window solution, which is the optimal one. I have also linked the video explanation for the previous problem in the description in case you would like to check it out. In this problem, we are given an array of integers and a value k. We need to check if there are any duplicate elements such that the two occurrences are at most k indices apart, and we will refer to these as nearby duplicates. The key difference between this problem and the previous one is that in the earlier problem we were simply finding duplicates, but here we are looking for nearby duplicates. Say we have this array as input. We can clearly see that the number 2 appears more than once in this array. But whether this 2 is considered a nearby duplicate of this 2 depends on the value of k. In this case, the two 2's are at index 1 and index 4. So the absolute difference between these two indices becomes 4 minus 1 is equal to 3, which is actually greater than the value of k. And as per the question, for two values to be considered a nearby duplicate, their absolute difference must be less than equal to k. So in this case, this is not getting followed. That's why this is not a nearby duplicate. So even though this 2 is a duplicate element, but it's not a nearby duplicate and the result would be false. As here the value of k is determining what is considered as nearby. Suppose we are at index 4. In that case, only the last k indices will be considered as nearby elements. However, if the value of k was 3 instead of 2, in that case, the index difference 3 less than equal to k would satisfy the condition and the result would have been true. One easy way to solve this problem is by using hashing. We can use a hash map to store the mapping of each element to its most recent index. Why the most recent index and not just any index will become very clear once I walk you through this example. So let's build the hash map as we go. We start scanning our input list and we are at 0th index. We can see that the first element is 1 and we will check if it is already in our hash map or not. We can see that it's not part of our hash map yet. So we will add the element 1 and its index to our hash map. The next element is 2 and still it is not in our hash map. So we will add 2 and its index. The next element is 3 and we can again see that 3 is also not part of our hash map yet. So we'll add 3 and its index to our hash map. The next element is again 1 and this time we see that another 1 is already part of our hash map and it has some index mapped to it. But now we have to check, is it within the k range? We check the absolute value of the current index minus the index of the previous one and then confirm if it is less than equal to k or not. For clarity, note that this is the key and value of the hash map and this is the k we are talking about. We can see that this value is actually 3, which is actually greater than the k value. So this one is not a nearby duplicate of the previous one. Now we will update the index of the new one in our hash map. So this 0 will become 3. This way, if we encounter another occurrence of 1 later, we will use this new index instead of the old index. This way, we will be using the most recent index of 1 to check the distance for the nearby calculation. Next, we reach the 4th index and here also we see a 1. We will again check if 1 is in our hash map or not and it's already there. So we will calculate the difference between the index of current one and the one that is already in our hash map. So that will come down to 4 minus 3, which comes down to 1, which is actually less than equal to our k value, that is 2. So this time we can say that this one is actually a nearby duplicate of another one. So we will return true as the result. And if we go through the entire list and do not find any nearby duplicates, in that case we return false. This approach takes O of n time since we scan the list only once, and O of n space, as in worst case all the elements can be unique and may go inside our hash map. But there is a better solution to this problem, one that improves the space complexity. It's based on the sliding window technique, and this problem is a perfect beginner-friendly example to understand how sliding windows work. We are given the condition absolute value of I minus j is less than equal to k. This means the absolute difference between two indices should be at most k, or in other words less than k plus 1. So what this is really telling us is we need to maintain a window of size k, and as soon as it becomes k plus 1, we slide the window forward to keep the size fixed. That is, we will remove the oldest element or the leftmost element so that the window size again becomes k. And we will keep shifting this window while scanning through the input list. In this problem, we will use a hash set to store the k elements currently in the window for faster lookup, because any lookup from a hash set can be done in O of 1 time. Now, while scanning through the list, if we come across any element which is already in our hash set, that means we have found a nearby duplicate and we will return true, because the size of the hash set will be at most k and it will store the most recent k elements. And if we finish the list without finding any duplicate elements, in that case we will return false. Sliding window can be easily implemented using a 2 pointers technique. Say first we will take 1 pointer left, which will indicate the starting of the window, and right will indicate the ending of the window. So we will actually use the right as the iterator. That is, we will use right for scanning through the list. So initially we are keeping our left at 0th index and our right pointer is also at 0, and the distance between our left and right pointer will comprise of our current window. Our right pointer is pointing to the element 1 and it is not in our set currently, so we add it to our set. So our window contains 1 element now. Next we move our right pointer ahead to index 1 and the element there is 2, which is also not present in our hash set, so we add 2 to our hash set. Till this point, the size of our window is less than equal to k, so we can keep going. Now our right pointer is at index 2, which is pointing to the element 3, and 3 is also not in our set currently, so we add 3 to our hash set. But at this position, the size of our hash set becomes 3, which is not less than equal to the value of k. So we need to slide our window. That means we have to remove the leftmost element, that is 1, from our hash set and move our left pointer by 1 to slide the window. So now our left pointer is at index 1 and our window has again reduced to size k. Next we move our right pointer to index 3 where the element present is 1. Now we check our hash set or window, but our hash set does not contain element 1. So we add it to our hash set. But again we can see that the size of our hash set has become 3, which is not less than equal to k. So we have to remove the leftmost element or the element pointed by the left pointer from our hash set. So we will remove 2 from our hash set and move our left pointer forward by 1. Now our window only contains 3 and 1. Next we go ahead and scan the next element. Now we are at index 4 where we see another 1, and this time we can see that 1 is already present in our hash set. So we can say that we have found a nearby duplicate and we can return true. If after completion of the scan still we haven't found any nearby duplicate, then we would have returned false. The time complexity of this approach is O of n, as we are scanning the list only once. And at any time at most k plus 1 elements can go inside the set, so the space complexity becomes O of k. So now let's quickly code this up. So first of all we will initialize our window using a hash set or simply set in Python, and then we will initialize our left pointer to 0. Now we will iterate through our nums array for num in nums. For understanding, you can assume that num is the element pointed by the right pointer. Now we will check if our current number is already present in our window, which we can check in constant time, that is if num in window, and if it is, then it's a nearby duplicate and we can return true. Otherwise we will go ahead and add the current number to our window. So window.add num. Now after adding any new number to our window, we need to check if our window size is exceeding the k value. So we will check if len of window is greater than k. In that case, we need to slide our window. That is, we will remove the oldest element or the leftmost element from our window. Window.remove nums of left. We can get the leftmost element very easily using nums.left, as we are using the left pointer to track the leftmost element. After this, we need to move our left pointer by 1. And after completing the entire scanning, if we haven't returned true yet, that means there are no nearby duplicates and we will return false. So this was a simple implementation for this sliding window problem. So let's run this. We can see that this is accepted and it runs efficiently. I have added both the solutions on my website DKodeTree.com. Feel free to check it out. In the next video, I will be covering contains duplicate 3, so stay tuned for that. If you found this helpful, make sure to hit that like button and subscribe to DKodeTree. It supports the channel a lot. Thanks for watching and I will see you in the next one.